This position information over because we don't need it anymore. We are ready to move on. We are going to take our average velocity calculations that we found super useful earlier, and we are going to create a velocity versus time plot. Before we do that though, we need to think about what it meant to have a consistent slope earlier. So in our position versus time graphs, we had slopes that were not changing. And I pointed out earlier that slope is equal to rise over run. Now, the entire reason that we are going to use this information about slope to calculate average velocity and then to plot average velocity is that the slope of a position graph is equal to velocity. So a position versus time graph set up like this. The rise is the change in position, in other words, the displacement. The run is the change in time, in other words, delta t. So if we go back and we look at the formula that we used earlier, and again, I'll go ahead and just block this off so it's a little bit easier to see, makes it stand out a little bit, is this right here. What we just pointed out, this is the rise of a position versus time graph. This is the run. So if we know that the slope was not changing right here, that means that the velocity had to stay the same, right? So whenever we plot velocity and it's staying the same, it's going to be a straight line, just a straight line on our velocity versus time graph. So what that means is that each of these calculations is going to produce a flat line in the graph. So in other words, let's go ahead and think about what this will look like. So each of these average velocities that we just calculated, so I'm going to label these as V1, V2, V3, etc. So V1 is equal to 2 meters per second. V2 is equal to 0 meters per second. V3 is equal to 1 meter per second. So remember that we're going to have some graphs that look something like this, right? We might have some numbers down here in the negative. This is going to be velocity, and then this is time. So the velocity over time is not changing, then we're going to have a straight line on our graph, right? So just kind of thinking ahead before we even actually make our graph, what we should expect a straight line for each of these. This straight line is going to be at 2 meters per second. This other graph over here, time and velocity, this is going to be at 0 meters per second. And then our final graph, velocity versus time, that flat line is going to be at 1 meter per second. So each of these is going to produce just a flat horizontal line in our velocity versus time graph. Okay, so let's go ahead and move this over right here. Now, whenever we're plotting these lines, we can do one of two different methods, which I'll come back to here in a second. But let's go ahead and set up our axes. So remember that in our position versus time plot, the first step that we took was to draw and label our axes. So we're going to do the same thing right here. And again, if you're worried about, well, am I going to be able to fit everything on my graph, then just go ahead and put your vertical axis down the middle of whatever space you're using to plot. And then do the same thing with the horizontal axis. Just place it right in the middle of your graphing area. Again, time is going to be the horizontal axis. And again, we're using seconds. Our vertical axis is going to be velocity. And look at our units, meters per second, right? I'm just going to flip this over real quick. Label velocity. and then meters per second. Ooh, it looks like I ran out of room. Meters per second here. Scratch this out, and we'll just rewrite meters per second. Okay, now what we want to do is, again, we want to look at our data, look at the biggest numbers and the smallest numbers. And for time, we're going to do our time axis just like we did before, right? So we're going to use the same range of time that we used for our position graph earlier. So it's got to go from 0 to 6 seconds. So over here, I'm going to go ahead and draw my tick marks just like I did on my position graph. And as you guys are graphing this, if it helps you, just pull out your position graph, look at it, and you can exactly copy the horizontal axis, right? Just the horizontal axis. You don't want to copy the vertical axis because, of course, we are graphing a different quantity. But for the vertical axis, you can just borrow the position graph. Okay, now for the horizontal axis, you can borrow the position graph. For the vertical axis, we're going to look at the values here. Our smallest number is 0, so we want to go a little bit lower than 0, right? We want to have some negative numbers dialed in there. And then our highest number is going to be 2 meters per second. So you guys can make 1 meter be equal to 1 block, or you can make it equal to 2 blocks or 3 blocks, as long as all your numbers fit in there. I'm just going to go with 1 block. So 1 meter per second is equal to 1 block. And I'm going to go ahead and just go from 1 to 5. So 1, 2, 3, 4 barely fits in there, and then 5. Then I'm going to do the same thing for my negative numbers. And again, you don't have to go as far as I do, as long as you have at least one number smaller and one number greater than your minimum and maximum. Okay, so we have velocity, we have time. Just like in our graph earlier, we drew the axes, we labeled them, right? The variable plus the units. And then we also drew tick marks. We used the information from the data, and we numbered the tick marks. So now that we've done that, we are ready to plot our data. Now there's a couple different ways that you can do this. You can create some points to plot their data, or you can split up your graph into a couple of different portions ahead of time based on the times that you used earlier. And so I'm going to go ahead and use that method because I do think that it's a little bit easier than doing time and velocity points. Okay, so here notice that we have from T0 to T1. Okay, so our first horizontal line segment is going to go from T0 to T1. So I'm just going to draw like a little dotted line at T0. And then I'm going to draw another dotted line where T1 lays. So this is 3 seconds, right? So again, draw a little vertical dotted line. Okay. And then I'm going to use a different color. I'm going to use purple this time. I know that my next time segment ends at 4 seconds, so I'm going to draw a dotted line down 4 seconds. And then my final time is TF, 6 seconds. So I'm going to use red, and I'm going to mark that end, so 6 seconds. Okay, so now we know we're going to have to draw 3 straight line horizontal segments. So we're going to look at these one at a time. So from 0 to 3 seconds, in other words, in this space right here, we need to have a horizontal line at 2 meters per second. So we're going to find 2 meters per second right here. And remember, I was using green earlier, so I'm just going to go ahead and use a green marker to draw that line. So you can draw a dot if you want at 0 seconds and 2 meters per second. You can draw another dot at 3 seconds and 2 meters per second. But you're basically just drawing a straight horizontal line inside this time range, which is the same time range that you noted earlier. Now I'm going to use my purple marker, and I'm going to draw the horizontal line segment for the second calculation that we did. So second calculation went from 3 seconds to 4 seconds. So from here to here on our graph. And the velocity we calculated was 0 meters per second. So I'm just going to go ahead and draw a straight line right here. Again, we can add dots if we want. That's up to you. One at 3 seconds, 3 seconds, 0 meters per second. And one at 4 seconds, 0 meters per second. Now the last one, I'm going to draw this in red. We can see that our velocity was 1 meter per second from 4 to 6 seconds. So over here, I'm going to find 1 meter per second over here, and then I'm going to draw my straight horizontal line. And again, I can add points to really just sharply define where that velocity starts. Now, you guys can, you don't have to. This is a clear, just only if you want to. Right here, the fact that these velocities overlap each other means that there's an instantaneous change in velocity. So it instantaneously changes from 2 meters per second to 0 meters per second. So you can draw a vertical line if you want to between those horizontal line segments. But again, you don't have to, because the data that we're really looking at is those horizontal line segments. And then that's it, guys. That's all you had to do to go from the position versus time data that you started off with. We went to calculate the average velocity. And then finally we got our velocity versus time graph at the end.